Welcome to the vBrownbag session. My name is Madhu Kashyap. I'm the Senior Product Manager for OpenStack at Brocade. And with me is Karthik Natarajan, Software Manager in the Software Business Unit of Brocade. So today I'm going to talk about the on-demand data center, and then Karthik will walk you through a use case. And with that, let's just get started with some key business drivers. With cloud networking, we want to bring the same operational model that exists today with data center compute and virtualization. So the key drivers here are agility, elasticity, scalability, the cost reduction, openness. These are all key drivers that force compute virtualization to go into cloud, and we're seeing that same operational model also come into the cloud networking and data center networking space. So how do you get new innovative services? How do you quickly get tenants onboarded with different network services? How do you keep your costs low, get your maximum utilization from your infrastructure, and at the same time reduce your dependency on any particular vendor? This is where OpenStack comes in, and again, inherent to Brocade's initiatives, we are totally embracing open source. Like I said, OpenStack is one of our key initiatives. Open Daylight is another one, and OPNFV, where we're all plugged into the open source community. So we really believe in that, and that is part of our DNA going forward, if you will. So if you look at the data center network automation space, you can see the spectrum of, on the far left, you have CLI, which was the more traditional network architectures where you had network engineers or operators using CLI to go configure the switches, routers. And on the far right, you see the the most latest sort of incarnation of data center networking with controller-based architectures. And there you see instances of the Brocade Viata controller and VMware NSX. And somewhere in the middle, you have different capabilities, including CLI scripting, through network fabrics, through Yang models and netconf APIs. So these can be used by other DevOps engineers, and including the Neutron plugins that we've done for OpenStack. So this is what a on-demand data center topology would look like. So you have your compute racks with lots of VMs. And also you can see interspersed into those racks a virtual load balancer, a vRouter, VPN as a service, firewall as a service. These today are virtual machines, but they're tenant-based, VNFs, virtual network functions that are dedicated to tenants. You have your underlay, which is our Ethernet fabric, the VCS fabric. You have the border core routers, the MLXs. You have physical firewalls, physical load balancers. This is what the data center is looking like today. And going forward, you might even replace that VCS fabric, which is a layer 2 fabric, with an IP fabric. With that, I will hand it over to Karthik, who will walk you through a use case that goes through an on-demand data center. There you go.
Thanks, Madhu. So let's look into the details on a 3-tier web application deployment. As you see in the picture, you have the database tier, the application tier, and the web tier, which is connecting to the internet. This is a typical topology that you will see. And if an OpenStack tenant wants to deploy such an application, they would need to use a few Neutron constructs to deploy them. For example, the web tier, the application tier, and the DB tier would need individual L2 virtual networks for isolation, because there is a lot of VMs connecting in these different virtual networks. We already had a brown bag on overlay support in our VDX products that goes into detail on that. In addition to that, you would also need the tenant router support that routes the traffic between these 3 tiers and also provide the external connectivity to internet. And you might want to protect your private network to from the internet using a firewall, which is the tenant firewall here. And for heavy demand scenarios like, for example, the Thanksgiving, Black Friday sale days, the tenant app tier might also need to burst into another data center for getting extra compute requirements. That means they would need to create some IPsec VPN tunnels. and there is also a load balancer in front of the web tier to handle the request from the internet. So let's start with the tenant router. As you see from the familiar horizon topology, you have the 3 tiers which are represented by the networks, and there are VMs connecting to them. There is also a public internet available on your left side. Now there is a tenant router that's connecting all these private networks to the internet, and that's going to do the routing between the tiers as well as connecting them to the internet. Let's say if the tenant wants to use a high performance and sophisticated virtual router, then they can use the Brocade vRouter VM, and for that we have upstreamed the vRouter L3 plugin that can perform vRouter VM lifecycle management automatically. And typically the web tier needs to get the floating IP access because we need to have reachability from the public network into the web tier, and that means the plugin will automatically generate the source NAT and destination NAT rules for you to connect these private networks to the public network and also provide the reachability from the public internet. If your private networks have IPv6 subnets, the plugin supports that as well, and the plugin can work with both the Brocade vRouter 5400 and the 5600 models. Let's get to the tenant firewall. It's the same topology, but then you want to protect these private networks from the internet, and the router is the one that's really connecting these private networks to the internet, which means you need to place these firewall rules on the tenant router. For example, you want to allow only HTTPS traffic from the web tier to the internet, and you don't want to expose your application and database tiers to the internet. That means if you have a vRouter deployed as a tenant router, you can use the Firewall as Service plugin to configure the rules on the vRouter VM. The plugin has the concepts of a trusted zone and untrusted zone. In trusted zone, we group all the router interfaces that are connecting to the 3 tiers of your private networks, and in the untrusted zone, we have an external gateway interface that's connecting to the internet. So the tenant firewall can apply the traffic filtering between your private networks and the internet, and it can just protect your assets. So next, let's look into the heavy demand scenarios where during the Black Friday days, you want to just burst into another data center and you want to just use the resources in them. You have 2 sites here, site 1 which is an OpenStack cloud and site 2 which is another OpenStack cloud. And if you see in site 1, there is an application VM that's connecting to 11.1 subnet, and in site 2 there is additional application VMs that's connecting to 17.1 subnet. But you want these application VMs to talk to each other across the internet between the data centers, and that means you would need to establish IPsec VPN tunnels between the vRouter VMs that you see in the picture. And if you have already deployed the vRouter as a tenant router in your network, you can use the Brocade vRouter VPN as Service plugin to configure these secure VPN tunnels between your data centers across the internet. And it can automate a lot of steps like internet key exchange policies, IPsec policies, which means negotiating the authentication algorithms and encryption algorithms and so on, so that the VMs connecting to 11.1 subnet can talk to the VM in 17.1 subnet, although they are in 2 different networks across the internet in 2 different data centers. If you want additional data center, you can create a new tenant level IPsec VPN tunnel to that data center also. And because you have these different subnets, we can configure the NAT exclusion rules for them automatically in the plugin. So it pretty much automates all this process and you can create these tunnels with ease. So next step is to orchestrate this whole 3-tier web application end to end. We have talked about a lot of components, but how do you orchestrate them with a click of a button? That's where Heat comes in. The OpenStack Heat templates supports all these Neutron resources that I have listed. The Neutron Net, which is for supporting your tiers, your private networks. and then you can create the VMs, Nova server VMs, which are connecting to these tiers. As I mentioned, there is also a load balancer in the front, and then a tenant router and firewall. We also talked about the IPsec VPN tunnel. Because we support all the plugins, and when you configure them, when you run the heat templates, the requests are automatically given to the plugin, and that means they can be configured in the vRouter VM. And in addition to these, Heat also supports auto scaling policies. If you want to do scaling out or scaling in your VMs within one data center. To summarize, with OpenStack, it's really easy to deploy your 3-tier web applications, and Brocade has worked with OpenStack community to upstream all their plugins and integrate their product lines with OpenStack. Thank you.